Another mechanism problem over here. So show the mechanism of products formed from the reaction of 2,3-butylene oxide. So if you've never heard of butylene oxide, we will write that out too. And then of course this reaction is with H3O plus. So butylene oxide. So first of all, bute means that you have 4 carbons over here. And since this is an ether, an epoxide kind of a thing, it means that between 2 and 3 you have an oxygen. Okay, so that's butylene oxide. Propylene oxide would be just this. Okay, so with 2,3-butylene oxide, I'm telling you the location of the epoxide. If it was just butylene oxide, it would be just 1, 2. But anyhow, no sidetracking. Let's get back on track. So here, show the mechanism of the products formed from the reaction of 2,3-butylene oxide with H3O plus. Okay, so here we have another acidic mechanism going on, and so it means that it's kind of like an acid-base mechanism again. So as soon as I know I have an acid-base mechanism, I look for my base, which is always going to be the oxygen here then, and protonate the oxygen. Okay, and so then I get an oxonium ion right here, and this ring is now highly stressed out because, of course, it is. As it is, it's stressed out before, and now the oxygen is even charged, so pretty stressed out. Okay, so another thing to remember here when you're dealing with H3O plus is that the only other thing you can have with you is water then. Okay, so you have water, you have H3O plus, and that's about it. You can't really use many more chemicals because it's not given to you. Okay, so don't try to create your own reagents as you're working through all of this. Okay, so now that we have to relieve the oxonium ion, so it means that these 2 carbons right here, these are going to be a little bit more susceptible to attack. So in comes the water, which is the nucleophile now, and this will attack the carbon at the back, and the oxonium ion will get relieved. So a couple things over here, okay, before I go on. So first of all, this is going to be a back attack, and back attack means that something is attacking from the behind, and it's coming from behind only because in the front you have the epoxide. Okay, so the backside attack is going to be important because why? It's going to give us the stereochemistry. Okay, so the other point over here before I go on is that you have these 2 carbons. Okay, which one of them are going to get attacked? In this case, both of these carbons are exactly the same. Okay, so it doesn't really matter. But otherwise, if you have something in an acidic medium, then the carbocation that is more stable is the one that is going to get attacked. Okay, so remember again that the carbocation that's more stable. Okay, carbocation more stable will be attacked. So that's how it works when you're working in an acidic medium. In this case, both of them are the same, so you can do it in either place. Okay, so all right, let's go ahead and write the product out. So here we have this. So as we said that there is a backside attack, so which means if there's a backside attack, then the H2O is going to be at the back. And just leave everything in there. Okay, don't get rid of anything yet. So here we have the water, oxygen attacked the carbon, so oxygen is the one that is bonded, and then this oxygen here, this is going to be then in the front because the other water came from behind. Okay, so one has to be in the front, the other one has to be at the back. So then the last step that is remaining now for me is to go ahead and deprotonate this oxonium ion, and so now I can write my product. And so this is actually a synthesis of diols because treating any kind of an epoxide with water, with acidic water, will give you a diol. And here you can see the stereochemistry is going to be anti to each other. The diols are anti to each other, so one is going front, one is going to the back, and that is really important when you're trying to write the products for epoxides, is to show the stereochemistry. Now 99% of the times it's going to be anti. The only times you will not have stereochemistry important for you is when you don't have stereo centers. Okay, but other than that you always have to write it out. Okay, so simple mechanism.